If I could just introduce Hector Altamirano, who's going to be speaking today about Santorini Key in Brighton.
Thank you very much, Mike. Yes, it's Hector Altamirano. Yeah. I'm one of the lecturers here at the IEDE, and also the course director of the MSc Environmental Design and Engineering. I was asked to present these two BP projects, the Santorini Key and One Brighton. And as you can imagine, presenting two massive projects in just 15 minutes is quite a challenge. So what I have done, I have just included here a few of the main findings that I think are common in most of the BP projects that were funded by Innovate. So how I move this? Okay, the aims of the building performance evaluation was to measure energy performance of new dwellings, to inform developers on how to build future homes, but also to help occupants understand how their homes perform and how to improve the comfort levels on them. The BP include two main phases. The first one, post-construction and early occupation, where we look at the fabric of the buildings. We run a number of tests, overheating test, thermal imaging, U-value calculation, pressure test. But also we look at the design intent and the team aspirations. We look at the guidance and home demonstration given to residents. And we look at the occupant satisfaction through the BUS methodology. We also look at the installation and commission of these houses, mechanical ventilation and heat and hot water system. And the phase two, which is in-use performance and post-occupancy evaluation, which is the long-term monitoring, more than 2 years of monitoring. And we look at the heating, electricity, and hot water consumption and the internal conditions on each one of these properties, relative humidity, temperature, and carbon dioxide. The first project is the Santorini Key, which is a regeneration project being built in Southampton at the moment. It considers commercial and community space and the construction of more than 1,600 houses and apartments. The development is located in southeast of Southampton. And the area that we assessed as part of the BPE was that indicated with the this one here, which comprised 168 apartments and houses. The project also looked at these three terrace houses, which were constructed with to code for sustainable home level 3. The heating and hot water was provided or is provided through a communal district heating, gas-led CHP unit, and gas boiler as a backup system. And the ventilation is provided by continuous mechanical extract in each one of those houses. Some of the findings. In general, people were quite happy with the location and the design of their buildings, the layout. They were quite satisfied with the comfort levels that the houses provide. And you can see here some of the, on the graph, some of the winter temperatures, internal and external, of the three properties that we monitor. And you can see that the levels are actually quite good for winter month. And the difference is between them is mainly due to the set point that residents program their homes. In terms of the fabric of the building, we found that higher heat loss and U-value comparing with predicted values, and being almost 70% higher for the measured U-value. This is not something uncommon in many buildings. Through the thermal imaging, we found a number of defects on the insulation, mainly wrongly installation and lack of it in many points. And also we found some difference between the materials being used on site and those that were specified in the construction drawings. This having to be something positive, it actually, the quality of the materials being used on site was higher than the materials on specified. We found a risk of overheating. Internal temperature during summertime on all houses exceeded the overheating threshold defined by SIPSI, and mainly on bedrooms, as you can see for the three properties, A, B, and C being monitored. We found that the measure flow at the extract terminals were much lower than the design values. You can see on the table on the top, the design trickle flows and the design boost flow differ from the measure trickle and measure boost flows, quite considerable. We also found that there was a steady decline in the performance of the ventilation system during the whole period that was the house was monitored. And some of the issues, or some of the performance we think that are related to installation issues, like for example, the flexible duct being wrongly installed, the trickle vents being covered by residents with these paper curtains, and some undercuts in doors were not being completely open. In terms of the district heating, the overall performance of the plant was not as expected, which seems to be related to the power to heat ratio and the heat distribution within the development. This means that the carbon intensity of delivered heat is more than double what will be expected from individual gas condensing boilers. I'm going to move to the One Brighton now. The One Brighton was designed considering the One Planet living principles, but also to be zero carbon, considering a number of renewables technologies. Heating and hot water is provided by the communal heating system, biomass, and plus a backup of gas boiler. Each apartment has a mechanical ventilation with heat recovery system, and we focus our attention on 5 apartments located in different floors and different orientation in One Brighton, and all of them with one bedroom, which is the one that you can see there, the layout on the right. Some of the findings. Occupants were quite happy with the many features of the building, the layout, the allotments provided, the bike storage, location, bins, but a specific, they highlight the green caretaker that has a major impact on the good performance of the facilities in the building. Also, occupants reported that the apartments are in general comfortable, although many issues were raised regarding the ventilation system, excessive dust, poor control, and poor flow design. You can see there one filter that we replace after 3 months, and according to specification, it should be replaced every 6 months. Also, some issues in the design with the position of the intake and exhaust vents. They are less than a meter apart, but also they are quite less than a meter from the next apartment. In terms of the energy consumption, what is quite good, in the graph you can see that the consumption of all apartments in One Brighton, 172, and specifically that the consumption of the 5 apartments we monitor, A, B, C, D, and E, and F, sorry. And the electricity and heat use is below design targets, 40% lower for electricity, as you can see, and 30% lower than a target for heating, which is quite a good finding. Also, we found a high risk of overheating, equally as at Santorini Key, for all 5 apartments and mainly in bedrooms, and during summer times, and you can see the graph on the left, the percentage of time that the temperature were higher than the threshold defined by CFC. Many residents understood that ventilation system was actually a cooling system, as specified in the manual given to them. And you can read there, keeping windows closed in summer will allow your MVHR unit to provide free cooling by letting in cooler air from outside and extracting warmer air from inside your home. So they understood that this was an air conditioning. We found that the efficiency of the gas boiler was good, as specified by the provider. This is related to the communal heating system. However, the efficiency of the biomass boiler was lower than the sub calculations. Reason for this? Well, it was not used as expected, mainly due to equipment fault and issues with maintenance. As a result, carbon emissions were 10 times higher than prediction, which is quite high. So, it seems that I have plenty of time now for the wider lessons, so it's great. So I put these 5 wider lessons. Evidence from both projects show that there can be several errors in sub-inputs and inaccuracies in U-value calculation. This discrepancy is not unusual at all. In terms of the commission of the mechanical ventilations, the main issues seems to be the poor installation practice and inadequate commissioning processes, which could greatly impact energy consumption, indoor quality, and mold growth and condensation. There is a high risk of overheating, which is likely to increase in the future if the climate change. The underperformance of community heating schemes, if not addressed, will seriously compromise the CO2 emission targets set out by the UK government for the construction sector. And I put this final one with learning and continuous improvement. And what I wanted to do here is I want to highlight the approach of the developer regarding these findings. At the beginning, they were not at all happy with the findings. However, they took several actions to improve their design, the communication within the company, and the processes on site, which is something to highlight. I want to also mention that as part of our program MSc, during these last 5 years, our students have conducted a number of studies for their dissertations, what you can see there, that are related to both projects, one Brighton and Santorini Key. And also, I didn't put it here, but with the, how is it called the program? I forgot the program now. The Retrofit for the Future, but I didn't put it here. And I want to finish to thank the UCL team. I hope that I'm not missing anyone, and the funders and partners. And I want to specifically thank Nick James, Chris Eaton, Julia Blaskett, and I forgot there Tom Cornell from TSB. So thank you.
Thank you very much, Hector. And as with the previous session, there'll be an opportunity to ask the panel questions at the end of this short session. So I'll now hand over to the next speaker, Paul Ciniglio. Hope I pronounced that correctly. My apologies.
Okay, good morning. I'm Paul Ciniglio from First Wessex. We're a housing association. I'm based in Portsmouth. We have about 20,000 existing homes, and we build typically about 300 new homes each year. We've been involved in 2 of the building performance evaluation studies, but I've been asked to talk to you about the Rauner Renewal project, which is a new development in Gosport of 700 units. First Wessex have 240 of those units, and they were to replace prefabricated homes which housed a lot of naval personnel. I'm going to be using Tassos's slides. Tassos is from the hub, and he knows the Rauner project inside out, having been involved with it all the way through. So please bear with me when I'm using his slides. We did run one of these sessions. We co-sponsored it in Portsmouth last November when Tassos presented on the Rauner project. So if you were at that, I apologise that I can't give you the next 20 minutes of your life back, but please bear with me. So the project here, you can see, I better just quickly show you a photo of the flats there. You have here 2 identical blocks of flats, 12 in each block, and they're mirrored. The 2 different energy performance standards in these flats, one was built to Code for Sustainable Homes Level 3, which is now the equivalent of minimum building regulations Part L. Although at the time these flats were built, they were constructed to 2006 building regulations. So both blocks were in fact built a step ahead of regulation at the time. And the other block was built to the Fabric Energy Efficiency Standards, which was the first step in the approach that the Hub advocated to government for introducing a zero carbon housing standard, which was due to come into play this year, but has unfortunately been postponed. Sorry, it seems to be jumping forward. But the fee standards here for the flats gave an absolute limit, a target of 39 kilowatt hours a metre square per year for your space heating and cooling energy demand. There's no renewable energy systems installed here. We trialed a type of modern method of construction, a thin masonry block joint. I'm sorry this keeps jumping forward. And all units had mechanical ventilation with heat recovery in, which is now actually a very common component and feature of new housing. So in terms of the difference in specification, it was actually fairly minor in actual fact. The fees block had an additional 50 millimeter cavity width, which was had an extra 50 millimeters of cavity wall insulation as compared to the code block. We have gathered a lot of data. We've gathered a lot of data about this project over a period of 4 years. The data was actually monitored by UCL. And it soon became quite apparent that there is evidence of this performance gap, and that this is representative of mainstream housing practice for new developments, unfortunately. Got a mind of its own, this, sorry. Maybe someone's operating it, telling me I need to move on a little bit. But so in terms of testing, I'd like to draw your attention to that. We did some staged air tightness tests, not just a test at completion. There was a lot of commissioning on the MVHR units. We did in situ U-value tests, and a co-heating test and thermal imaging as well. We worked closely with the design team and the on-site guys, so they were aware of the study that we were going to be undertaking. I did push the button that time, so that's good. And one of the things we did find was that there wasn't really a clear definition of where the airtight and thermal barrier was within this building. And of course, that's important to identify so that we can avoid unwanted penetrations of that layer. Also, you can see here that there were some problems with the MVHR ductwork layout, some quite severe ones there. Obviously, we shouldn't be using any flexible ductwork. That system will not perform as it was intended, and it didn't, in fact, no surprise there. But one of the things to note here is that this isn't just about on-site control. The builder here did have a bit of a difficulty because the way the timbers in the ceiling were arranged formed a barrier to him being able to get the ductwork through. So while on-site quality and overseeing that is very important, we all have a role to play in narrowing this performance gap. I'd like to also draw your attention to, you can see there we've got some thermal bridging, actually quite severe where it's white. That probably suggests there's a bit of moisture in the cavity there. One of the reasons for that was when the blown beads were put into the cavity, you can see that they didn't make their way through the lintel profile here. I also, one of my favourite slides is this Juliet balcony here, which you can see is fixed back to the wall and is in fact acting a bit like an external radiator. So it's very nice for keeping your hands warm when you're being serenaded from the pavement. So we did post-occupancy evaluation on 3 different flat type typologies. I won't go into a lot of details about those, but there were varied levels within the blocks. And the monitoring program, we had meters on all the gas installations, the electrical installations, water, and we also looked at electricity to the MVHR units. In addition, we looked at the internal conditions, very important for the occupants. So we had relative humidity sensors, CO2 sensors for air quality as well. Okay, I've got to keep up with these slides. So, right, so post-occupancy evaluation, air tightness testing. We did, as I said, some stage testing here, and this was interesting. The target for the air pressure was Q4 here, and there was quite a struggle for the contractor to get down to this level. A lot of silicon was used to get down to level 4, and the fact that we have MVHR specified here suggests that we're not going to get the maximum efficiencies out of that as well. But I think what's most interesting here is coming back and doing the testing 2 years on. You can see the degradation or the deterioration in that air pressure test results. One of them actually getting worse by over 50%. Some quite big variations, no surprise, in the actual annual gas consumption measured data here. And of course, this is subjective to the occupants, and would suggest that we probably need a much bigger sample size if we really wanted to learn something from this. Similarly, electricity, there's variation there, but all flats tended to use less electricity than was predicted. Here we can see where the electricity was actually used, a breakdown. Hopefully you can see that by the boiler, the cooker, the MVHR, fixed lighting, which in reality was very low, and also appliances. We're actually in a water-stressed area in the south of Hampshire, so water consumption is important. The predicted target here for the code was 105 litres a person per day, and again, there was a mix of consumption there. I did actually monitor one scheme with the Environment Agency, and we had extremes of as high as some people using 300 litres per person per day of water in their flat with no apparent leak. So we used a buzz survey, which I'll tell you a bit more about shortly, to have a look at the occupancy satisfaction, the POE here. And what we found was the normal euphoria of getting your new home. Everyone's very happy, more interested in getting the furniture through the door than someone coming out to ask them what they think about the new home. But when we went back slightly later, that had dropped off a little bit. People still generally happy, but not quite as high as when they moved in. But there was certainly a general lack of understanding of home user manuals. They weren't presented in the most clear manner that would really benefit the residents. Residents also reported that they were generally comfortable throughout winter, but when it came to summer, there were already some grumblings about it getting a bit uncomfortable during the summer period. The buzz survey is measured on a scale of 1 to 7, don't ask me why, but fairly decent satisfaction levels there with the units. Here we can see the parts per million of CO2 measured, which gives us an indication of the indoor air quality, and pretty well we were below the 1,000 ppm threshold, so that suggests that we have satisfactory indoor air quality. And similarly, humidity levels were within a good range. Hopefully the MVHR was helping there. So some of the conclusions here. There was actually very little difference between the two blocks, the fees block and the code block. And that's perhaps not that surprising. There's only an additional 50 millimeters of insulation in the cavity walls there. As you've just seen, very little difference also in the gas consumption. Nothing really discernible to see between the two blocks. Because we had problems with the MVHR, I think that the MVHR actually had to be commissioned on 3 occasions, and it wasn't right each time. They hadn't got the flow and the airflows and the balancing of the system right. So, this is a problem that the people installing this were convinced that they commissioned it correctly, but it just wasn't balanced each time it was checked. As you could see, there wasn't fantastic continuity of the insulation in the fabric through the thermal imaging that was carried out, and some overheating issues were noticed. I'll go on to that. I know the Hub are doing a lot of work on overheating, and I really say to you, this is the issue that we need to get a grip on in the future, in the very near future. Actually, I think this is going to be one of the things that could really make our homes unsuitable to live in all year round, which makes them unsustainable for a new home. At First Wessex, we don't mind. Well, I don't mind saying that we have got a lot of overheating problems. We've been honest. We know we're not alone. It's not peculiar to us. So we're trying to assist with understanding what's going on here. We have a lot of new flats with communal heating systems, and we've been doing monitoring over 2 years, getting a lot of data, and at least a third of those are failing the CIBSE TM52 standard, and a lot of complaints, really uncomfortable. We've had residents of one scheme actually remove a window that was restricted. Such was their frustration to take that window out. Again, you can see here where we monitored the different units for overheating. The monitoring actually extended to having sensors on the windows, so we got a good understanding of what was going on. I won't go into too much detail about these results. You can take a look at the slides afterwards, but again, we did have some flats in this fairly typical low-rise flatted development which were failing the overheating tests. So just drawing towards a close here. As I think I've already said, there's very little difference between the fees and the code blocks. The MVHR, we weren't going to get the best out of that because the air tightness wasn't really as low as it needed to be. But with overheating, it's particularly the single-sided flats, single aspect flats with windows which are often restricted, trying to stop people from falling out of windows. So we do have a lot of unintended consequences there. So just drawing it to a close, what's important for First Wessex now is we take the learning from the BPE programs and, sorry Justin, we take the learning from these BPE programs and put them into our design guide, so we hopefully don't fall into the same trap when we're delivering more homes in the future. I've really enjoyed working with the Zero Carbon Hub and Innovate UK. The Hub have really got a very important role to play. They've been fantastic at bringing together all stakeholders across industry, and I really feel this work must continue. It is that important. You know, if we're looking at a new affordable home in London being £460,000, probably the largest investment anyone will make, you know, we really do need to narrow this gap in performance and actually eliminate it, because no other sector would get away with this. Thank you very much.
Thank you very much, Paul. I'm delighted to say that our final speaker is here. So if I pass you over now to Justine Bere. Thank you.
Yes, we at Bere Architects did 3 BPE projects: Camden House, which is a domestic house in London, Evervale Social Housing, and a non-domestic as well, but we're concentrating today on the 2 domestic projects.
I think a couple of people can't hear.
Okay. Can you hear better now? Yeah. Why did we want to do the BP projects? Well, it was because we were completing some of the first passive house buildings in the UK, and we wanted to know if our buildings were performing okay, and to know if our buildings were healthy, and to record occupant responses to their homes, to record whether the passive house methods work in the UK, and might be surprising now, but I had quite a lot of people telling me in about 2007-8 that it was a Central European approach that wouldn't work in the UK. To know if we could do better next time, and we wanted results with the veracity given by academic partners. So of course we got the best academic partners from UCL. I was hopeful of good results, and I wanted to use the results to influence government, industry, and the general public. So this wasn't a commercial enterprise. It was primarily to try and influence people. That's why I came to architecture, not for commercial reasons, but to try and find ways to help make change in a sort of really problematic sector of the economy. So firstly, the Camden Passive House. The team you can see there, it's a domestic house, North London. Quite sort of light in area and conventional, modern, contemporary house, looking from the inside. Plans, you then notice quite relatively thick walls. Line of air tightness noted in the red, which is very important, as Paul just mentioned. And the build-ups, quite substantial amounts of insulation. Getting to generally sort of U values of 0.1, that sort of thing. So then the first BPE results. The air tightness achieved was better than the passive house requirements. The tracer gas tests, which were done by UCL, to verify the air tests, the pressure air tests, really confirmed that. Co-heating tests, Sam Stamp of UCL, is doing a PhD here. I think he's just passed his Viva. Did 2 tests. The first one when there was quite a lot of sunshine, and so he came back a year later and did another one, because the first one was a bit optimistic. The second one was showing that the building is actually performing slightly better than design in overall heat loss. An in situ heat flux, so checking all the U values, and again they were conservative by design, so they were actually slightly better, in fact, than design. And thermal bridge analysis, so there was thermal bridging study and a thermography study, and results were pretty good. Well, Sam Stamp then noted in his second report the indications of Camden Passive House is one of only a few co-heating test dwellings that meets its design intent, and so we're very pleased with that, and very reassured that what we're doing was a good approach. And then comparing the space heating demand to average UK building stock on the left there, Part L, compliant buildings, and so on, predicted and measured. And you can see that this is a really tiny space heating demand compared to even the fees standard. And then electricity demand, predicted and monitored. There was a little bit of problem at the beginning where a solar pump had been incorrectly wired and it was running constantly. But apart from that, once that was sorted out, the overall electricity result was very close to what was the design. Lights tended to be left on, and if lights weren't left on as much as they are, then we'd probably be better there than, consistently better. I mean, some of those graphs, some of those columns are better than predicted. And then dividing up the proportions, the pie of energy use, and you see space heating is roughly the proportion that was predicted. Sockets and blinds were less. So it's the lights that are a little more, well, 2 or 3 times more than design. And then, so monitored versus predicted space heating demand. Again, in every case there except one, every month except one, the monitored usage was better than predicted. Compare that with the annual energy performance with benchmarks, and again, really very, very encouraging. Even if you look on the left-hand graph compared to the energy use aspirations of a Code 6 building, very good. I mean, this building didn't have the PV on the roof that the Code 6 building obviously does have. And then looking at overall gas and electricity consumption compared to the other sort of top performers in the UK to date that have been monitored, I should say, as in the UK. And Princedale Road is another passive house building, and it's a terraced house. So this is a detached house. It's very, very encouraging. Psychrometric graphs then. January, so typical winter temperatures, always, and it's obviously the combination of temperature and relative humidity up in the very comfortable, and then you can see there the green at the bottom is the outside temperatures fluctuating pretty steeply, and look how relatively small the fluctuations are on the internal temperatures in the winter, and then in the summer. Mostly very comfortable, some of them wandering out a little bit of the SIPC guidelines. but then you can look at the big spikes on the green again in the summer of external temperatures, and look how smooth the inside of the building is and how it irons out those fluctuations in temperature. Well, we can perhaps talk about overheating in a second in the questions. 6.5 minutes left. Then the overall comfort of the occupants has been, they've classified it as really top points. CO2, it's of air quality. The air quality most of the time is high, classified as high, and you can see the sort of less satisfactory is very, very occasional. And usually it's just for about 30 minutes, 40 minutes after a shower, there's a spike, and that's quickly whisked away by the heat recovery ventilation. And then the perceived health, again, of the occupants in the last survey, they regard the building as more healthy. So then, hopefully, we'll be a bit quicker on the Limehouse and the Larch House. Again, with UCL, we started off with Cardiff University on some of the on the co-heating and the fabric tests. Haven't got the co-heating results here, but they're similar. They're very, very close to the actual to the predicted. So the approach there, similar. This was using Welsh materials. In the Limehouse, we were pretty well totally Welsh materials. We even we designed and had certified and manufactured passive house windows made in Wales. And you can see the line of air tightness again in that diagram on the right as you zoom in, always really, really important. And then because we were teaching people who hadn't done this before, we had the idea of doing staged drawings. So you can see this is the first 2 stages, and then the drawing builds up. So they get things in bite-sized chunks, rather than looking at the drawing on the right and thinking, how the hell where do I start? And then risk management, so discussions with the contractor on air tightness techniques and so on. And note on the left the surface penetrations. I think most people know about these gaskets now, and that's there for a future supply. But never assume that message has got through, because one of the first findings we found in the BP was thermal imaging that there was a big cold patch behind a BT box, and it turned out that a BT person had come on a day when the site manager wasn't there, and drilled a hole right through and then covered it over with a box for future. So it wasn't evident what he'd done. The heat recovery, ventilation, design and commissioning, really, really important. It's possible that Ian Mordaunt might have something to say about that if he's here. I know he's doing a meta study. I can't really say anything about that, but it's very, very encouraging across the BP projects how some buildings are performing very, very well in their heat recovery ventilation, and a lot of that I have to say is down. I unashamedly mentioned Andrew Farr, the Green Building Store, who is absolutely superb in design, and if you get him to do your heat recovery ventilation, you will not have a problem, I'm quite sure, as long as you've got even semi-diligent workmanship, because he'll find any problems in the commissioning. But one of the real problems is people changing filters. And you'd have thought it was a very simple thing for people to do. Set a timer, set an alarm in your diary and change it. But people don't. And I think there's a real business opportunity for someone to, and I try and get Green Building Store to do it, but it seems to be too much for them to take on. But someone could find out who's got heat recovery units installed around the country, and there are now plenty of them to surely make a business once a year, just going and turning up and changing the filters and charging via direct debit an annual charge for doing this. Well, actually, I would say more than once a year, once every 6 months, really. So what we were aiming for was in the Limehouse and the Larch House on the right-hand side, the PV giving us sort of negative bills. We didn't achieve the generation that we had hoped. The electricity demand here against the typical UK is that slightly sort of greyed out one, and the Larch House with that spike is what actually happens, and that's because they between about 4 and 8 o'clock they do a lot of cooking, and in Germany they are people in social housing do have their cookers and their kitchen appliances provided for them, and they are double, triple A rated. But here the tenants bring their own, they bring the cheapest possible, and they're pretty energy consuming. So that, in the context of everything else being very low energy, so that explains that spike. I haven't actually checked the results. If anyone's doing a study and would like to carry on doing some monitoring, the equipment is still in there monitoring data, but it'd be the tenants have got a much more efficient cooker now, which they said they were going to try. It's a little sort of some kind of infrared thing on a tabletop. They said used a lot less energy. So 2 minutes. So this is summer generation against use. So in the summer we are, this is the Larch House, is generating a lot more energy than it's using during the middle part of the day. In the winter, not. And that's what we now are concentrating on projects. We need to be doing what we're doing in the summer and the winter in order to reduce peak load demand. And that will then mean that money can be diverted from power stations into buildings. If we can reduce that peak load, and we're doing it now. It's easy. It's not that difficult, I should say. Humidity levels all within the optimum band. That slightly greyed out band, pretty well all within the optimum. Larch House as well. This is winter humidity. Those little spikes are just showers which just quickly whisk away. One of the most important things we did was, I think, looking at the cost difference. So this is if energy prices are stable, and this was converting what we'd done into estate scale housing. So whereas there might be £35,000 difference for a house builder to build the passive house at the beginning, the occupants are going to, even if prices don't go up, are going to be saving £75,000 over a 50-year period. And what happens if the government predicts we get 5% energy rise? There's a graph that roughly equates to 5% energy rise. It's £170,000 over 50 years, and all for the sake of £35,000 now. Now, don't let anyone say, where are we going to find the money for this? Without first asking, where are those people going to find the money? Because they're going to have a much, much bigger problem than we've got. We've simply got to find the money to do things properly. And that's what happens if we get a 10% energy rise. Are we really seriously going to be, without any concern, passing that on to next generation? So that's what we learnt, and I'll stop there. Thank you.
Thank you. Thank you very much, Justin. And we've got some time now, about 15 minutes for some questions from the panel. And Professor Bob Lowe of UCL-Energy has actually joined us on the panel. He worked alongside Hector and other colleagues on the first couple of projects that Hector spoke about. So again, if you could wait for the microphone to come to you, please. Can we kick off with any questions then, please? There's one right at the back there.
Hello, my name is Nzube and I'm with Capita. I have a question for Justin. looking at the examples you had on your slide, I noted the Camden property. I think it's Ranulph Road, and I read through your book, if you will, on passive house design, and there it mentioned that the client, in that case, actually wanted a passive house building, so that sort of helped to get that process going. However, I've worked on several projects where, domestic and non-domestic, where you mention these principles to the client, to the architect, and the rest of the design team, and the immediate reaction you get is, oh, it's too expensive, or too much capital cost. They feel it's over-engineered. They feel that the contractor might say, it's not. The ease of construction is a lot less, so it'll impact on cost and program. And then often things just sort of whittle down to just naturally ventilate the whole thing, and away you go. And it'll be built nice and cheaply. And as long as it meets its BREEAM rating, everything will be fine for a non-domestic case. But my question is, how do you, or how have you, been able to convince not just the client or the prospective building owner, but also the design team about the benefits of passive house design? So, low energy consumption, good indoor air quality, potentially good daylighting if the fenestration's designed quite well. How are you able to impress that to the design team and get them to sort of buy into the idea?
Thank you. Yeah. Well, actually, the owners of the Camden Passive House didn't initially have in mind a passive house, to my knowledge, and they were persuaded. In that case, it was partly, I have to say, on grounds of planning, because they felt that they would get a better chance of getting planning permission. The person. But the daughter has some severe asthma, and when she was a child, she was actually hospitalised with asthma, and she now occupies the house. And I think the parents probably had in mind, when I started talking to them about the health aspects of the quality of air, that they started to think, actually, this would be a great place for the daughter. And that really, I think, was what really got them on board. So the other things to talk about are comfort. People are and condensation. I mean, I kind of forget that most people actually live with condensation on a daily basis, and it's really really funny when they say, "What? There's no condensation at all?" Of course not. And so it's health and comfort, and now I suppose I have a slanted angle because we get loads and loads of people coming to us and just saying this is what we want in the first place, so I don't have to persuade anyone anymore. Actually, if I have to start trying to persuade them, I lose interest.
Thank you, Justin. Can we move on to the next question then, please? There's just one here and then.
Andrew Burke. It was a question really for both Paul and Justin. Airtightness, you had design values, and Paul, you were saying you were getting much worse. Justin, had design values and you were getting a bit better when you measured them, which actually means there's quite a challenge as to how you design the ventilation system that's going to produce good indoor air quality when you don't actually know quite what your air tightness levels are. Potentially, in Justin's case, you might be under-ventilating and so could be getting indoor air quality problems. Your difference is different, it's marginal, but the design values that the designer would have used will have been assuming more air tightness than you were actually doing. But obviously it's a problem for Paul as well. I'd just be interested to know what the panel's views are.
Just to say quickly that the great thing about the BP results show that in spite of the Larch House having an air tightness of 0.2, well actually just under 0.2, the air quality inside is excellent. So that little difference between 0.2 and 0.6 is irrelevant, really.
Yeah, I was going to add that I think our targets in this country are woefully inadequate. Building regulations, 10 metres cubed metre square an hour at 50 pascals. I mean, you can pass that with a window ajar upstairs. Really, it's a terrible standard, and I think in housing associations we've got a lot better at building to more airtight levels. The code and experience of passive principles and passive house have driven us that way. I think most designers in SAP will probably set the target slightly leniently in case there is difficulties on site with achieving that. And yes, I mean the MVHR really important. It's just not going to function correctly probably unless you're down below 3, I think. But we've got our own in-house contractor and building a dwelling to passive principles, and they've managed to get down to an airtightness of 1. But they're really surprised at the effort it takes to deliver that. Of course, it's not a linear scale. The lower you go, the harder it is. And I think the intermediate tests will help a lot, because if you don't test at mid-construction, then it's going to be too late to actually improve that.
Bob, did you want to make a point?
Just very briefly, I think the idea that we should be wary of designing our airtightness properly, just in case we get our mechanical ventilation calculations and installation and commissioning wrong. That the solution to the problem is to get everything wrong seems to me to be I don't know, perverse. That's probably the best way of putting it.
Okay, actually, there's an interesting. We didn't go into our BP results, but one of the recommissioning checks on the ventilation unit resulted in the ventilation unit being switched off in the Camden house by mistake for about 2 weeks, and the occupants didn't actually notice the difference, which I find amazing, because I'm sure the bathrooms must have been a bit pooey, but they didn't even notice the difference. And certainly, the CO2 levels were nothing anywhere in sort of health concerning levels.
Thank you. I think
Just
you had a question just on the front earlier.
Do you think that the current trend and the government's encouragement for self-build is an opportunity, because in addition to skills on the continent, there's much less of a speculative market, so people are more interested in whole life cost, or it means we're going for smaller scale contractors and that's much too hard for them to upskill? I know it's crystal ball gazing, but...
Yeah, I think self-build is is a tremendous opportunity for people, and we're doing this with a kind of a concept called naked house. So the timber frame is actually put up as a draft-free construction with windows, with the ventilation, all the mechanical equipment in there, and people can then fit them out and finish them off themselves, and save a lot of money that way. And also, one of my directors is working on a wiki house concept where people are actually able to print out, on CNC cutters their own buildings. So that again, I think, has fantastic potential.
I'd just like to make one observation first of all, which is, Justin, my experience of your work is that you essentially knit your own supply chain for anything that's really important. And I think that's a very interesting comment on the, I would say, mainly the structure of the supply chain generally in the United Kingdom. And I'd just like to come back to the point I made earlier in the previous session about the relationship between training and contractual and incentive structures. And it seems to me that we really cannot put incentive structures second. If you don't pay people to do the job, if you structure things so that they get paid more, if they don't do the job, then many of them, I'm afraid, will not do the job. And that is what we observe again and again. in BPE.
I'm just going to go to the next question, if I could, perhaps, but if you've got time, then perhaps you can make it then. So I've got one question down here at the...
Good morning. It's Sean Fitzgerald from Breathing Buildings and the University of Cambridge. It's regarding the passive house, so I subscribe to supporting the principles within passive house in terms of trying to create a low energy building design, but with a critical eye on which of those are appropriate for the UK climate. So it doesn't surprise me that actually when the ventilation system was turned off, it was still okay, albeit a bit of a surprise for you, but actually with the building fabric and everything that's been done, that's actually a very large part of the prize available with passive house. Most of our experience is in non-domestic buildings, and what we find is that in non-domestic buildings in a climate like the UK, the value of the heat recovery component for the ventilation is fairly negligible. In fact, it's negative because the electrical load that you have. And I said in non-domestic, you can shake your head, but that's the analysis. In the case of domestic, I was just going to ask, has an assessment been done regarding bearing in mind the heat gains for the climate that we have in the UK? Is the heat recovery component of the ventilation system, I mean, it may well be that a mechanical system is actually completely appropriate, but is the heat recovery component been thoroughly investigated for domestic use in the UK, and therefore is that the lowest energy solution?
I think you actually need a building physicist to answer that question, and if Wolfgang Feist was sitting here, I'm sure he would very, very plainly explain. But yeah, I mean, it's a hygiene ventilation, so it's you have the runoff road. CO2 levels, I can't remember the figures, went up to sort of 7,000 parts per million. Many school classrooms. I did a yoga class and it was 7,000 parts per million. Pretty stuffy, horrible for me, but actually a lot of people don't so quite notice that. So we've got very, very high quality air and coming in at a sensible temperature. It's not a cold draft. So if you didn't have the heat recovery, people would be feeling a cold draft and they try and switch the thing off. Where they don't get that. In your point on the non-domestic, we visited some years ago. We visited schools in Belgium, and they were we went with Bill Bordas and various people like that. And Bill Bordas got very rightly excited about the fact that the ventilation units were running 24 hours a day, and that was wrong. You get sort of you get a build-up of I forget how he described it, but anyway. So if and then I put Bill Bordas in touch with Frankfurt City, Dr. Axel Brecht in Frankfurt City, who'd been developing an approach for schools, passive house schools, and Bill was then completely understood and convinced. And Axel Brecht pointed out that the Belgians were doing it wrongly. They had been come over, they were shown what to do and they weren't. And what they should have been doing is designing the ventilation, and the same applies to offices as well, ventilation to come on during occupancy. And there are different ways of doing that. It can either be a simple time, it can be presence sensors or whatever, and it goes off at night. And then, of course, if you have any heat requirement for the building, then you put it separately. You don't put it through the air. So it can work very, very well in a non-domestic environment without using as much energy as it saves. So I don't know how the figures stack up, but they're about 10 times. You save about 10 times more energy than you use.
I think Paul just wanted to make one quick point, if you would, please, Paul. Yeah. I think we'll have to end for...
I think there's plenty of evidence now that shows that passive house is performing much closer to the original design intent. I think my worry is, are we going to deliver 200,000 to 300,000 passive houses each year in this country? But self-build, you're probably not using a design and build contract. You specified out the details. You got the transition of the professional team all the way through. And I know Innovate UK have found that there could quite possibly be a bigger gap with design and build contracts. But just one thing on MVHR was I'm still looking for someone to tell me categorically, do we have summer bypass or not? And we really need to be answering those questions, because you know, I'm just a practitioner. I want some clarity on that. I would say yes, we should always have it there.
Great. I think we'll have to draw it to a close there, unfortunately. That's the end of that session. We will, after lunch, move to the non-domestic cases. Thank you very much indeed to all the speakers this morning. It's 12 o'clock now. We'll